Okay, well, I know you guys probably are still working on the other dimension drawings, as I can see looking around. I'm going to give you guys a couple more today, a couple different ways to dimension, and then you'll have the rest of the time to finish those other ones up and then do these new ones today. So a couple things I want to look at today include dimensioning a slot. So these came up the other day and I said I would come back to them. So I'm going to talk about that for just a minute. And specifically looking at the way we call out the radius of the size of this slot. So a lot of people will look at this and think it's missing a value, that it should say a radius or R15 or something like that. And it's not, because the radius of this actually comes from this dimension over here, the 30 dimension. So if I were to come in here and actually put in the radius of 15, I'd actually be over dimensioning because I'd be putting that value in twice. So the ANSI standard requires that you just put in a leader that shows the letter R. And that's a note basically for the radius, and that we need to look elsewhere to find the actual value. Now to locate the center, it's dependent upon the function used to create it. So if it is punched out, then we call out the centers. If it is machined, then we call out the quadrants to show the overall width of the cut in both directions. And then we also locate the centers separately, but at least showing it off of this direction. So again, it just depends on the process. So as we do some of these with slots, if we don't know the process, then I'll accept either way as long as they're fully dimensioned. So we're going to see one today, or a couple of them with the R leader on it. The other thing that we're going to look at is a bolt circle. And before I do that, let me go ahead and look at this example here. So this is in your textbooks on page 8-103. So chapter 8. Oh, I'm sorry, that's the figure name. The actual page number itself is 225. So this transmission cover right here is what we're going to get into. And I'll talk about the ordinate dimensioning in just a few minutes. But what I want to focus on are these R's to call out the radius. And the radius values themselves in this case are called out by these ordinate dimensions, excuse me. So the center is up 2.95 from 0, and then the quadrant is 3.8, so that would tell me I'd have a 0.85 radius there. But again, we're not going to actually call out the value, we're just going to put in the R as you see it here. And I'm also going to show you how to get the leader tool to do this with the arrow on the inside. So switch back to my laptop here. And in order to do this, you could use the regular leader tool. I don't like using the leader tool because of something I mentioned the other day, and that is that a leader should always be pointing towards the center of the arc shape that you're working with. So with a leader, I'm able to do a lot of other things other than point to the center. So I'm going to recommend that you guys use the actual radius tool, and then I can click to place the radius, and then I'm going to double click on the value and just delete and replace it with R. So one of the few times we'll actually replace the dimension text with something else. Then I'm going to select the leader and just hold my mouse over the grip here. I'm not going to click on it, just hold over it, and I can choose flip arrow. And so now you can see I've got the arrow to the inside. To get the rest of this line, it's controlled by the dimension style, and I don't want to completely override the style because I still might want the radius dimensions elsewhere normally. So you'll use properties to finish the rest. So I'm going to right click and select properties. You can also type CH and PR, both work. But in my properties palette, we're looking for the fit category here. And this line right here that says dim line forced, we're going to set that to on. And as you can see, when I do that, I now have the radius line as shown in the book. So you'll have 3 different ones, one up top as well, and this little one that you'll do that too. Okay, so the other thing that I want to look at on this drawing is putting in ordinate dimensions. Now this drawing is going to be kind of different than some of the other ones because, oh no, I'm sorry, the other one's going to be scaled differently. So this one's a 1-to-1 scale. I'm still going to put them in paper space. Notice that I've put in all the center marks for all the different little points there. And when I go to put in my ordinate dimensions, the important thing is that I have the origin at the correct spot. So I'm going to leave this up for now, and I'm going to do what you're going to do, and that is start a new drawing based on the ANSI template to get this one started. If we switch back and look at the book and take a look at where the actual origin is, the 0, 0 is at the center of this big circle. So probably the quickest way to draw this is to actually start at 0, 0. And then the radius, you can see, is 2.36. It comes out 2.36 each way. So I would recommend from the start that you do your circle and you just put in 0, 0 as your base point, and I think it was 2.36 as your radius, and that'll get you started in the right spot. I will show you too, though, if you did not do that, if you just started drawing it out in space, then you could change your base point. You can move it to your circle by typing UCS. So UCS stands for User Coordinate System. I can then just snap to the center here. Straight to the right is X, straight up is Y. And then if you take a look at my coordinate readout, actually I can't show you both at the same time zoomed in, but I'll do this a little bit. There we go. So if I hold it over the origin there, you can see my coordinate readout down below is showing me 0, 0. I can't snap, but you can see it's really close to 0, 0. So either draw around 0, 0 or move the UCS afterwards. And that's important for ordinate dimensioning because ordinate dimensioning builds off of wherever your 0, 0 is. So to put in my ordinate dimensions, after I've got everything drawn and I've got my center points, I am going to make sure I'm in the dimensions layer. And then the ordinate dimension is in the drop-down list next to our dimension tool, and there's ordinate. And it works pretty similar like the regular dimension, except you don't click 2 items, you're just doing 1 at a time. So I'm going to click the center of this circle and bring it straight down, and you can see that that's going to be 0. And I'll just hit the space bar to repeat. Bring this one down, track off of that one, and there's my next one. Rather than track, I'm going to recommend that you draw some construction lines here. That'll make it go a little quicker because now you can just snap straight to the points here. And so eventually I'm also going to dimension the quadrant of this circle as well. Now if you have some really close together, this one's going to be dimensioned up top, so that one won't be in the way. But if you do end up with some close together, you can actually add a little jog in the line just by grabbing the leader and moving them apart as well. This is commonly used in sheet metal manufacturing, or also this one's just stamped out as one piece, but you'll see it a lot in sheet metal manufacturing. So any questions on how to place those dimensions? Yes, Keith. Oh, good question. You know what? Right there, I was just showing you there on the model. Since this one's 1-to-1, either way would work. But just to be consistent, I've been telling you guys to do it in paper space, so go ahead and do it in paper space. But yeah, since it's 1-to-1, it'd look the same. The next drawing is not 1-to-1, so it'd be quite different. So let's look at the other drawing and talk about dimensioning a bolt circle. So this is 8-101, adjusting locking plate, which is on page 224. And first of all, let me talk about actually creating this shape. So you're given a diameter of 0.5 for the overall shape and a thickness of 0.09. This view makes it seem like 0.09 is really thin, but it's really not. It ends up being kind of thick, as you can see here on my drawing. So that's the first thing I want to point out. Second thing I want to point out is creating these little teeth. So when you go to create these teeth, you'll be doing some arraying. So I'll just give you a quick example of this one. Let's see if I can get all these real quick. Dang it, I have to do a rectangle. There we go. Okay. So if I do a circle at the center here with a diameter of 0.2, so a radius of 0.1, and then another one with a diameter, so this one you can see in the textbook is called out, the inside's a diameter of 0.2, and then it shows us the difference between them is 0.02. So in that case, my radius is going to be 0.12 now. So that'll give me the top and the bottom of the teeth here. And then in order to create that first tooth, they're showing you that it's 5 degrees each direction from vertical. So with that in mind, I'm just going to draw a line from the center up, and I'm going to rotate it from the center 5 degrees, and then I'm going to draw another one straight up, and I'll rotate it.
You're on the wrong screen.
Am I really? Oh, drives me crazy. Thank you. Sorry. Well, let me do that again. Okay, so I'll go from the center straight up, and then I'll rotate that about the center there 5 degrees. Just going to go counterclockwise, and then I'll do another one from there straight up, and then I'll rotate it -5. And then that's going to give me what I need to create the little tooth in there. I can do some trimming. And then I can do some arraying and trimming to get all those teeth in there. So that's the strategy for getting that tooth in there. Now this particular drawing is small. I mean, the diameter is 0.5. So even at full scale, it would be a really small drawing. So on this one, and of course I'll have this on a slide for you to look at, this one you're going to scale 8:1. You're going to scale it up quite a bit. But if I actually tried to put dimensions in model space, they're probably going to be pretty big. No, I got annotative scaling on, so it would be okay as well. I think it'd be okay either way. A couple things you're going to do to this one as well. You're going to show some material. So you'll see there in the book that it shows a knurled pattern. I'm going to use my hatching layer, and I'm just going to use either the arc tool or the spline tool, either one, to create a series of arcs. So I'll just do some tangent arcs here. I'll keep it simple. And then you're going to hatch using the ANSI 37 pattern here to represent the knurling. And then I might have to adjust the scale. I'm going to go 0.125 for an 8, since I know I'm at an 8 scale. So that way it'll represent the material there. And then you'll have a leader with a note for the knurling, just like the book. So when actually dimensioning and calling things out, you'll want to put in a bolt circle. So using the center tool, I'm going to draw a circle from the center that runs through all of these little circles. And then you're going to dimension what that diameter is. Now in the book, when they dimension it, they don't call out the BC for bolt circle. And I won't count it wrong if you don't, but you really should. So I put BC for bolt circle. after that value. So would this be, let me do this again. Aside from the fact that it's in the wrong layer, is that an appropriate dimension there? No? It's not. Is that an appropriate dimension?
Not just like that.
Right, okay, yes, true. I'm going to need to add more to it. But I wanted to remind you guys, again, if it's a hole, a negative cylinder, then you'll call it out in the circular view. If it's a positive cylinder, then it needs to go in the longitudinal view. So instead of the diameter 50, it should be over here. And again, if I double click on it, I can type %% or use the symbol drop down to get the diameter symbol there. Now again, I just quickly put that in there. I didn't space it, but that should not be there. So what John was alluding to is how many holes do we have here? 12? So 12 times. There you go. And then I can also put in, I can't remember if your book shows the angle between them. Yes, it just shows the 10 for those. So the thing about a bolt circle is it can be dimensioned several different ways. And I think, you know, a lot of times it just comes back to the company, if you will, that's doing it. So I'm just going to create a little construction line here real quick. So one example, and the ANSI standard actually allows for multiple different things on this one, but one possible way, it doesn't let you dimension to a center line or a, yeah, so I got to put in another fake line there real quick. To there. So one standard might say that if there's 12 spaces that you're going to put in 12 times 30 degrees to lay that out. But then you might also see it just simply like this, where it just has the text of equal spaced after it. So either one of those is acceptable. Obviously that one's a little less work, but both will work for a bolt circle. And then on this one, you're also going to put in some center lines on each of these circles. So I'll show you that real quick after you get all the circles laid out. Oh, by the way, when you put in a note, a dimension, such as, well, I'll just say this one right here, it puts in that big center mark. Kind of showed this a little bit the other day. If that's interfering with one I already drew in there, then I can go to the properties and then center mark, set that to none. So you'll probably draw in your own center lines because you want them to come all the way out here. So you guys remember how far center lines are supposed to overlap on an English unit drawing? 0.125. So if I offset 0.125, it's huge, especially if I'm talking about these little circles here. So I don't want to do that. So what I've got to do then is I need to take into account that I am printing at an 1/8 scale. So I'm going to take 0.125 and divide that by 8. Let's try that again. 0.125 divided by 8. Roughly 0.016. We'll round that off. 0.016. So that's what I want my offsets to be on this one. So offset 0.016. Try that again. 0.016. Then you can see I've got the more reasonable spacing. So what happens then when I print this on the piece of paper, this is going to be 1/8 of an inch. This gap is. And what I wanted to show you on the centers of these circles is to make these centers, the line itself, point to the center of the circle every time. So don't just put vertical center lines on all of these. Take this one and then let's do a polar array about this center. Let's do 12 of them. And then that way you have your center is pointing to the center of the circle each time. So your transmission cover should end up looking a lot like the book. The other thing that you're going to need to do, though, is you're going to need to label all these holes. So we need to fully call them out and dimension them. So I'm going to use my text tool, and ANSI standard, we're using 1/8 inch tall text. So if it's not already 0.125, change it to 0.125. And then I'll call out whatever the holes are based as they are in the book. I just got lucky and happened to choose A on the right hole there. And what I would recommend that you do, because typically in drafting we like a really nice uniform look to our text, is once you get one in there, I would copy that one from the center of the circle to the other ones. So that way the text is nice and uniform. Now sometimes something's going to be in the way and you're going to have to move the label out, and that's fine. It happens. And then finally, you're going to need to put in a table here in Paperspace. So if you haven't done a table before, or if it's been a while, it's here in the annotation section. Here's the table tool. If I take a look at the table that you're going to create, doesn't have an overall title, but it has some header rows. It has 5 data rows here and 2 columns. So I'm going to go 2 columns.
You're on the wrong.
I did it again. Thank you. Still getting used to using the laptop in here since I'm recording. So 2 columns, 5 data rows. And then the first row is going to be headers, second row data, and data from then on. So there's not an overall title. So then if I go ahead and click OK, click to place it, then I can go ahead and put in what these values are. So A is 0.30. Whoops, my zoom went crazy there. Table's a little big, so I can resize it. Can change the alignments in there to get them aligned nicely using your tools up top. And then the last thing that you're going to need on each of these is, and we talked about this last time with dimensioning, is we need some notes to tell us more about the part. So this one we don't create a side view to show that it's 0.12 thick. That's just a waste of drawing. We just need a note that says what that material is and how thick it is. So same thing up here. Although we will do the side view so that we can do the longitudinal dimension and show the knurling on that one. Got it that time. So I think I have each of these kind of completed, so I'll pull them up on screen so that you can see them. So there's the final dimensioned one. I actually put my ordinate dimensions in on the center layer so that I had these center lines that came out from the shapes instead of just solid red lines. Either one would be acceptable, but the center line's nice since they're going to the center of most of those things. So I'll take it either way. And there you can see my cleaned up table after I resized it and made the text nice in there. And then the other one. So there's the 2 views of the locking. And you can see on the teeth, I just did the 18 teeth equal space instead of putting in the angle between them. Now I did put in the angle of the tooth itself, but I didn't put in the angle between them because they're just equal spaced. So those are the plans for today. Again, if you need to finish up the other dimensioning, you can do that first, or you can do this first if you want while it's fresh in your mind. Totally up to you. Let me know if you have any questions.